Hello, in this video we're going to take a look at finding the absolute extrema, the absolute maxes and mins on a given interval. And for these examples we are going to be looking at a closed interval. Alright, so our first example we have f of x equals 2x cubed plus 20x squared plus 50x plus 3, and we're going to look at that on the interval from -8 to 0. Alright, in order to find our absolute extrema, we need to find our critical values, and to do that we need to take our derivative. So if we take the derivative of this function, 2x cubed, our derivative is 6x squared. The derivative of 20x squared is 40x. The derivative of 50x is 50, and then the derivative of 3 is 0. And we need to find our critical values, so we need to find anywhere that this function is undefined or equal to 0. Polynomials are always defined, so the only critical values for this are going to come when it is equal to 0. And this is a quadratic function, so if you don't see the factors, you are more than welcome to use the quadratic formula or completing the square method on this. But I do see a common factor here. If we divide all of these are even numbers, so we can divide out a common factor of 2, or factor it out at least. When we do that, we get 3x squared plus 20x plus 25, and then you can use any one of a number of different methods to factor that. And the factors that you should come up with are going to be 3x plus 5 and x plus 5. You can FOIL that out and check. 3x squared will give us our first term. 3x times 5 is 15, plus 5 times x is 5x, and when we add that 15x plus 5x, we do get our middle term of 20x, and then our last two terms, 5 times 5, does give us 25. Alright, we do not have an x on this first one. We didn't factor out a GCF of x out here, and so we will not have any critical values coming from this first factor of 2 because it will never be equal to 0. But our other two factors can be equal to 0, and so we'll set those equal to 0 and solve for x. We'll subtract 5 and divide by 3, and we get -5/3. And then on this one we subtract 5 and we get -5. And so now we just need to look at our interval and find all of our critical values that lie in that interval. So in this case, both of our critical values, -5/3 and -5, are between -8 and 0. And so we will be looking at both of those critical values as well as our two endpoints. And so we are going to plug those into the original. So anytime we're looking for the absolute max and mins, we're plugging in the original. If we're looking at increasing or decreasing, remember we plug into our derivative. And if we're looking for concave up or concave down, we are going to plug into our second derivative. But for this one, we're only interested in that original value, and we will evaluate that function at each of our endpoints and then at each of our critical values on that interval. So we're going to find f of -8, f of 0, f of -5/3, and f of -5. So we're plugging in each of those x values in for our x in our original function. And if you plug in a -8, you should get -141. If you plug in 0 in for x there, you should get a y value of 3. Plugging in -5/3 is -34.04 rounded to 2 decimal places. And then if you plug in -5, you will also get 3. You can do this a number of ways. You can just plug in on your calculator, or you can put your function in on your y equals and then look at your table. Alright, so now we need to look at these and identify our biggest and our smallest number. So our smallest number here is -141, and then we actually have two biggest numbers, we get 3 shows up twice. And so this one will have an absolute minimum, our smallest, of negative 141 at our x value here is negative 8. And it will have an absolute maximum of the y value is 3 at our x value of 0 and at negative 5. And so our absolute max and mins are there. All right, let's do another example. Here we're looking at the function f of x equals 6x over x squared plus 3. And we're going to look at this on the interval from negative 3 to 0. So the same approach we did last time, we need to take this derivative to find our critical values. Notice that our domain of our original function here, x squared plus 3 in the denominator, is never equal to 0, because if you take any number, square it, and add 3 to it, it is going to be at least the value of 3. It will never be equal to 0. And so we do have a domain of all real numbers here. When we take this derivative, we're going to use the quotient rule. So the bottom, as it stands, times the derivative of the top, derivative of 6x is 6, minus the top, as it stands, times the derivative of the bottom, the derivative of x squared plus 3 is 2x, all over that bottom squared. And we will see that this is going to always be defined because we have the same argument. Our denominator is never equal to 0. And so if we distribute our 6 here, we're going to get 6x squared plus 18. And then negative 6x plus 2x is negative 12x squared over x squared plus 3, quantity squared. And then combining like terms there, 6x squared minus 12x squared is negative 6x squared. We still have our plus 18. So we did say that this is never going to be undefined, but it is going to equal 0. And so it'll equal 0. We can multiply both sides by that denominator. And if we multiply anything, our denominator times 0, we're still going to get our denominator on the left. On the right-hand side, that denominator is going to cancel out, and we're left with just our numerator. And so if we move our 6x squared to the other side, we'll get 6x squared equals 18. Dividing that by 6 will give us x squared equals 3, and x equals plus or minus the square root of 3. And now we need to go back and look at our interval. We're looking at the interval from negative 3 to 0. So the only critical value that is in that interval, the only one we are interested in, is the negative square root of 3. And we're going to plug into our function our two endpoints, negative 3, 0, and then our one critical value, the only one we're interested in, is the one in our interval. And so we're going to plug in negative square root of 3. We are again plugging these into our original function, so we're plugging in to the function 6x over x squared plus 3. If we plug in a negative 3 into that function, we will get a negative 1.5. Plugging in 0 will give us 0 in the numerator, and plugging in the square root, negative square root of 3 is going to give us, rounded to 2 decimal places, negative 1.73. And so again, we want to identify our maximum and our minimum. The smallest number we see over here is that negative 1.73, and the biggest number we see is 0. That's giving us our max and min. So our absolute min is negative 1.73 at the x value of negative square root of 3. And our absolute maximum is 0 at that x value of 0. And that would be our answers. All right, I'll see you guys next time.